Okay, so I said we were going to be talking about four of the four functional groups. And so far we've talked about alkanes. The next two are very similar, alkenes and alkynes. That's how they're pronounced. Alkene is E-N-E and alkyne, Y-N-E. Okay, so let's talk a little bit about alkenes. Alkenes have at least one double bond. Okay, so what does that look like? Well, in a line angle formula, it could look like this. It could look like this. Or it could look like this. Sometimes you might have more than one, and that's okay. I'll show you how to name it when you have more than one. But all you need to do to be an alkene is to have at least one double bond. Alkynes, on the other hand, have at least one triple bond. How does that look? Either of these two notations is correct. So those are alkenes and these are alkynes. Okay, let's talk about nomenclature for alkenes. If you're still having a little bit of a hard time getting this nomenclature business, what I want you to do before you go on watching is to go and look at your homework and try to start naming some of those alkane compounds. If you can get a little bit of practice, I'm not saying do them all, but do maybe like 4 or 5 of them, just so you can get the whole 5-step process under your belt. If you can get a little bit of practice on that, all the rest of the naming should be easy for you because we're following the exact same procedure for everything. Okay, so the first step in alkene nomenclature is the same as in alkane nomenclature. Only there's just a little bit of a twist. Identify the longest carbon chain with the double bond. Now, I don't care if your double bond chain has 3 carbons in or 20. It has to be the chain that has the double bond because there's no good way of naming that as a substituent. For example, this is going to be your longest carbon chain because you have to have the double bond in the chain. See also how I numbered that? We want to number so that our double bond has the smallest number possible. That's called getting priority. Okay, 3, 4, and 5 are the same as for alkenes. Oh, for part 1 you're going to use the parent plus your suffix here is going to be ENE. Because you have an alkene, your suffix is going to be ene. That's pretty self-explanatory, right? So here we have 7, that's heptene. Now, it's pretty easy. The stuff is pretty intuitive. It's not like it's going against what you think you should do. But there are a lot of chances to go wrong because it's pretty detail oriented. So you're going to have to make sure that you're really paying attention when you're working this homework or quiz or when the final comes around. if you're watching TV or playing with your kids while you're doing this, you might be making mistakes. So you want to try to make sure that you're, you know, pretty much focused. Okay, so then 3, 4, and 5 are the same as for alkanes, as far as your rules go. Okay, so we just did heptene, and that's good, but now we have to identify this substituent here. That's a 2-carbon chain, so 2 is ethyl. 2-ethyl. Now I left out a little space there, because something has to go in that space. And here's where things get a little bit different. Step 6 is to number the double bond. And you're going to do that right before the parent name. Okay, so what you're going to do is just put the first number of the carbon that occurs in the double bond. So here, this double bond is between carbons 2 and 3. So you're just going to write the 2. Remember here, you have word, number, word. That means there has to be dashes in between those numbers and words. Okay. Hang on a sec. Okay. Now, I wanted to copy this because alkyne nomenclature is the same as alkene nomenclature. Okay? So here we're going to do alkyne nomenclature. And here we're going to identify the carbon chain, the longest carbon chain with the 3X bond in it. And here, instead of using the suffix ene, we're going to use, the suffix yne. We're going to number the chain so it has the triple bond with the lowest number. So if this is my compound, we're going to start numbering so that that triple bond has the lowest number. We would start from the left. This is a 7-member ring. And so we're just going to do this the same way. Here we have 7, so that's heptine. The triple bond is at the 3. And we have 2 substituent groups. We have 2 methyls, and they're on 5 and 6. So we're going to write 5, 6 dimethyl to identify those. 5, 6 dimethyl 3 heptine. That's how you name that. Okay, let's do some examples of both of these types of compound. That's a tricky one. Okay, so I think you should pause it and then come back and get the right answer. 6, 7, 8. So this compound would be number from right to left here, then my substituent, that methyl group, gets to have the smallest number, so I'm going to do that. We will have 2-methyl, 2-butene. Now, I obviously have these parent names memorized just because I use them. I don't expect you to memorize them, but after you work with them long enough, you'll be able to know what they are. Just sort of like the elements. Now, see that trick? That's what I mean by being tricky about stuff. So on the 4 carbon, there's actually that methyl group there. That's the substituent. 4-methyl 2-hexyne. See how that suffix really matters, what you use there? You're going to want to be careful when you come to the homework problems on that, because that might trip you up a little bit. Okay, now the last functional group that I want to talk about will be very brief. And this is benzene, or the aromatic functional group. Benzene-containing compounds are called aromatics. It's not because they have aromas, they do. If you want to smell something that it's a benzene-containing compound that has a very strong odor, Bengay has an ester of benzene in it, and so if you happen to have any of that at home or at your work, smell that, and you can smell a little bit of the benzene action in there. It's an aromatic. It's not, we don't call them aromatics because they smell. It has a specific chemistry meaning, but I'm not going to get into that. Benzene looks like this. It's a cyclohexane shape. It's a 6-membered ring, but it has alternating double bonds on each of the members, so that means that it's as fully unsaturated as possible. There can only be one H on each of these carbons because it has 3 bonds to other carbons. Let's just take a look at this here, what I mean. This carbon here, this is like my close-up view here of this particular carbon. Here are its 4 bonds. 1 to the H, and then 2, oh golly, that's bad. That's 1 solid bond, and here we have a double bond. So 1, 2, 3, 4. And this is benzene. There are a whole bunch of different compounds that have benzene in them that are useful in medicine. I don't want to spend too much time on this though, because it gets really complicated, and I don't want to bog you down with all the details on this. But if you see this compound, you should be able to recognize it as benzene. As far as naming goes, we're not going to learn a step-by-step process for that. Okay, so I hope we've done enough examples of each of these different types of organic compounds to get you started. If you have any questions about any of these examples that I've done, or about any particular ones on the homework, please feel free to send me an email or call me anytime. I should be most happy to help you. Everyone has been doing so much better in the course, and I really appreciate all of your positive attitudes. Homework 4 seemed to go over pretty well for each of you. I haven't graded the exams yet, but I'll be sure to get that to you as soon as I can. Thanks so much, everyone. Have a great week.